Hello everyone, my name is Akshat Mishra. I am a student of Bennett University of BTech CSE branch in third year. Today I will be talking about a wireless technology known as GIFI. In this video, we will be going over the introduction to this technology, the evolution of network over the years, why should we use GIFI, a brief overview of this technology, its competitors, and the comparison between technologies like Wi-Fi and Bluetooth. We will also be going over its architecture and working and its advantages over existing technologies and also its applications. For many years, cables have ruled the world. The optical fibers played a dominant role for its higher bit rates and faster transmission. However, the installation of these cables caused high inconvenience and thus people opted wireless technologies. For the network evolution, we started with cables, then we turned to optical fibers, that evolved to Bluetooth, then to Wi-Fi, and then to a technology which is not very popular. WiMAX stands for Worldwide Interoperability for Microwave Access. It's a communication technology for wirelessly delivering high-speed internet service to a large geographic area. Can provide a speed up to 15 megabits per second in a 3 kilometer coverage area. And then we come to our current technology G5. Why should we use G5? The commonly used wireless technologies today are Bluetooth and Wi-Fi. They have many shortcomings like slow rate, high power consumption, low range of frequency. The maximum bit rates of Bluetooth and Wi-Fi are 800 kbps and 11 Mbps respectively. The power consumption in Bluetooth is about 5 megawatt and in Wi-Fi it is about 10 megawatt. The frequency of operation is very low, that is 2.4 GHz. Because of these few reasons, people decided to shift to G5. Let's know about the technology itself. It stands for Gigabit Wireless. The man behind this technology is Professor Stan Skafidis. He is from the Department of Electrical Engineering and he leads the Melbourne Science of Engineering research in nanoelectronics. GIFI is the world's first transceiver integrated on a single chip. It operates at 60 GHz frequency band. It allows a wireless transfer of data up to 5 gigabits per second within a range of 10 meters. It satisfies the standards of IEEE 802.15.3c. It utilizes a 5 mm chip and a 1 mm wide antenna, burning less than 2 milliwatts of power to transmit data. Now let's compare these three technologies, Wi-Fi and Bluetooth and G5. As for the data rate, the Bluetooth gives us 800 kbps while the Wi-Fi gives us 11 Mbps. In case of G5, the speed bumps up to 5 Gbps, which is a huge improvement. As for the range, the Wi-Fi's range is 100 meters and both Bluetooth and G5 operate on a limited range of 10 meters. The specification authority for G5 is NICTA. For Wi-Fi it is IEEE and WECA, and for Bluetooth it is Bluetooth SIG. G5 is a new technology, so it started developing in 2004 while Wi-Fi was around from 1990s and Bluetooth came into action in 1998. As for the power consumption, G5 consumes very less power as compared to the remaining two. It consumes less than 2 megawatts, while Wi-Fi consumes 10 megawatts and Bluetooth consumes 5 megawatts. As for the frequency, both Wi-Fi and Bluetooth operate on a frequency of 2.4 gigahertz, while the G5 operates on frequencies greater than 57 gigahertz. Primary devices for all three technologies are almost similar, so we do not need to go over that. Let's come to the architecture of G5. The core component of the G5 system is the subscriber station, which is available to several access points. It supports the standard of IEEE 802.15.3c mm wireless band, and 802.15.3c based system often uses small antenna at the subscriber station. It also supports line of sight operation. Let's see how G5 works. It uses a time division duplex for both transmission and receiving. Data files are converted from IF range to RF 60 GHz range by using two mixers. We then feed this power to amplifier, which feeds millimeter wave antenna. The incoming RF signal is first converted to an IF signal centered at 5 GHz and then to normal data ranges. It uses heterodyne construction for this process to avoid leakages due to direct conversation. Due to availability of 7 GHz spectrum, the total data will be transferred within seconds. Now let's talk about the advantages of G5 over Wi-Fi and Bluetooth. It allows high-speed data transfer, that is a speed about 5 gigabits per second. Its power consumption is relatively low, that is around actually less than 2 megawatts. It is highly secure, it is cost effective and also very small in size. It's a 5 millimeter chip. It also has small form factor and it can be deployed very quickly. Because of its small size, it is highly portable and highly mobile. Let's now talk about its applications. In household applications, it makes the wireless home and office of the future. It can also be used in office appliances as it transfers data at high speeds that made work very easy. In case of video transmission, it can transfer data at a speed of 5 Gbps, so it will be highly useful. Can also be used in broadcasting video signal transmission systems in sports stadiums and also in intervehicular communication systems. In conclusion, I would like to say that the G5 integrated transceiver chip may be launched by the starting of next year, that is 2023, by NICTA, which is National Information and Communication Technology Research Centre in Australia. Due to less cost of chips, many companies are looking forward to launch it with lower cost. Within 5 years, we can expect this technology to be a dominant technology for wireless networking, replacing the Wi-Fi and Bluetooth. We can also say the era of wireless homes and offices is near. I would like to thank you for watching my video.